I came up with cosecant of, watch your signs, cosecant of x cotangent squared plus cosecant to the third x. And then you could factor out a cosecant x out of the entire expression.
Is it wrong if you don't do that?
Just I would get in the habit of always doing it. And the reason why is because you really need to be on the lookout for Pythagorean identities now. So especially when you factor out a cosecant of x, notice you get a cotangent squared plus a cosecant squared. So 99.9% of the time, factoring out the GCF is a good habit to get into, because what could happen is you very well could do some kind of Pythagorean identity substitution to get a much cleaner, much simplified answer. So when I factor out a cosecant h, cotangent squared plus cosecant squared, I just redid that hexagon. Remember that hexagon to help you remember those Pythagorean identities. Remember how this hexagon works? Sine squared plus cosine squared equals 1. 1 plus cotangent squared equals cosecant squared. So cosecant squared minus cotangent squared equals 1. So this is very close to being a Pythagorean identity substitution of plugging in 1, but the sign's not right. Okay? But what you could do, what they could do for you, is you could rewrite cotangent squared as cosecant squared minus 1. And they could substitute this expression and they could rewrite the whole thing in terms of cosecant squared on you. So for example, they could rewrite this as a cosecant x times, change the cotangent squared into cosecant squared x minus 1 plus cosecant squared x. And then combine your cosecant squares. So when you see those squares, that's why you want to get in the habit of factoring out GCFs, because it could take you one step further when you're trying to check your answers tonight for homework or you're trying to take a multiple choice test. All right, any questions on that? Like I said, in terms of free response in calculus, it is okay to leave it alone like this. But you do have half the test is going to be multiple choice, and they are going to simplify these all the way down on you. All right, any questions on that example? All right, let's take a look at some other examples here. In your homework tonight, ladies and gentlemen, not only are you going to be doing the 2-5 homework from the book, but it also says to complete pages 19 and 20 in your note packet. So make sure, so whatever problems we don't do on page 19 and 20, I will be checking to make sure you finish up for homework. So let's take a look at example 3. Find the equation of the line tangent to the graph, y equals secant x at x equals pi over 3. Again, tangent line. What two things do you have to know? You have to know the what? Slope and point. Hasn't changed. So again, they're giving me the x value of pi over 3. I need to find the y value. So I need to plug pi over 3 into my equation for x. So, oh my goodness, now you got to remember your unit circle. This is why I can't say you can forget all your trig. There's lots of trig in calculus. So now you got to go back to your unit circle. Hopefully you saved your flashcards. Go back and review them if you need to. What is the secant of pi over 3? Well, secant's reciprocal of the cosine. So the big question is, what's the cosine of pi over 3? 1/2, and then the reciprocal of 1/2 is 2. So the point's going to be pi over 3, 2. So now I need to find the derivative to help me find the slope. So what is the derivative of secant x? The derivative of secant x is secant x tan x. Remember, the c's have the negatives. That helps you remember. All the c functions will have a negative as the derivatives. So now I need to find the value of the derivative at pi over 3. So I have to plug in pi over 3 for x. So I have to find the secant of pi over 3, tangent of pi over 3. Well, we just talked about the secant of pi over 3 being 2. So now I need to remember, what's the tangent of pi over 3? Square root of 3. So that tells me my slope is going to be 2 times the square root of 3. So now I can plug this and I can write the equation of the tangent line in point slope form. So y minus 2 equal to the slope of 2 times square root of 3 times x minus pi over 3. So let's take a look at this example. Find all the x values in the interval negative 2 pi to 2 pi at which the graph of f of x equals x minus sine x has a horizontal tangent line. What do you know about the slope of horizontal lines? 0. So I know that this is where my slope is equal to 0, which means this is where the value of my derivative has to be equal to 0. So to figure out where you're going to have horizontal tangent lines, you're just simply going to take the derivative and you're going to set it equal to 0 and solve for x. So first I have to find my f prime of x. What is the derivative of x? The derivative of x is 1 minus. Derivative of sine x is a cosine of x. So there's my f prime of x. So now I have to set my derivative equal to 0. So this is asking me, where is the cosine of x equal to 0? So think about your unit circle. Where is cosine equal to 0? 1, you're right. So where is cosine equal to 1? 0. 2 pi. Now remember, I'm looking in the interval from negative 2 pi to 2 pi. It's also negative 2 pi exactly. So there are the three answers. 0, 2 pi, and negative 2 pi. Remember, at pi, cosine is equal to negative 1. Okay? So any questions on that? So this is where solving all those trig equations, we really use a lot of solving trig equations in calculus. All right, any questions on that? Let's look at another question. Find the velocity at time t. So remember, velocity is just your first derivative. So when they ask you to find the velocity, they're just asking you to find the first derivative. So they're giving me that x of t is equal to t plus 2 cosine of t. So to find my velocity, I simply have to take the derivative of x of t. So what's the derivative of t? The derivative of t is 1 plus, what's the derivative of 2 cosine of t? Negative 2 sine t. So any questions on how I found velocity? When they ask you about speed, speed is just simply the absolute value of the velocity function. So speed, you're simply going to take the absolute value of v of t, which is just your first derivative. So all I'm going to do to find the speed at t is equal to pi over 2, I'm simply going to take pi over 2 and plug it into my first derivative. So I know that v of t is going to be, or v of pi over 2, excuse me, is going to be equal to 1 minus 2 times the sine of pi over 2. And then I want to take the absolute value of that. So what's the sine of pi over 2? It's just going to be 1, so I have 1 minus 2 times 1. So what's my speed going to be equal to? My speed will just be equal to what? 1. And typically there'll be units, we'll assume it's meters per second. No problem.
On a test, if we aren't getting units per second, because we're like units per second?
Yeah, that's fine. Units are, yeah. So, another way they could ask you about when a particle is at rest. When a particle is at rest, that is when your velocity is equal to 0. So I'm simply going to take my velocity function, the 1 minus 2 sine t, and set it equal to 0. So again, these are different variations that I can ask you about derivative. Again, we've been talking about horizontal lines, we've been talking about tangent lines. You also can be asked about rest, speed, and velocity. All right, and then we can solve from there. Okay. So like I said, ladies and gentlemen, make sure you finish up pages 19 and 20 as part of your homework for tonight.